Welcome to a lesson with Dr. Powell. Let's take a look at the derivative of the natural log of x. Okay, so when we compute this derivative, let's rewrite things a little bit. What if we put both sides inside of the e function? Then this side would just become x, because natural log undoes what e does if it goes into it. So we have x on this side, and we have e to the y over there. Now, this is like output, and this is like input. We can take the derivative with this notation, dx dy of this function, e to the y, remembering that the derivative of e to the x is just e to the x, but here we're thinking of y in place of x. Now, we have something very interesting. We started with y equals natural log x, and what we have done is we've computed dx dy. Now, if we're thinking about points, like if we have a point on this function, which is xy, if we go to the inverse function, which is across the line y equals x, things swap. Yx. In particular, if I have a slope here, so I have a tangent line. Let's suppose we have a tangent line, and the run right here is dx, and the rise is dy. Then the tangent line that's over here on this side is going to be swapped, because y's and x swap, so rises and runs swap. So here, this dy is actually going to appear right here, and this dx is actually going to appear right there. So that the slope of this tangent line, which is represented by dx dy, is actually the reciprocal of the tangent line over here, which is dy dx. So if we want to compute the derivative at the point xy over here, and we know over here, if x is representing the output and y is representing the input, that the slope is represented by dx over dy, the slope of the tangent line, then the slope right here at this point is going to be dy over dx, which will be the derivative. The derivative over here is going to simply be the reciprocal of this. So pretty much all we do on this to this equation is we take the reciprocal of both sides. 1 over e to the y is equal to dy over dx, which is the slope of the tangent line over here, and where this is a point on the function y equals natural log x, and therefore it's equal to the derivative of natural log x. So this right here is the derivative of natural log x. So the derivative of natural log x at the point x is equal to 1 over e to the y. Where y and x are related right here by this equation. So now what if we want to write this in terms of x? Well, we already know what y is in terms of x. It's natural log x. So let's just put it back. Let's just put it right in. So we put it right in. And we end up getting 1 over e to the natural log x. So we end up just getting 1 over x. Why do we get 1 over x? That's because e to the natural log x is just x. So this tells us, in summary, that the derivative of natural log x is simply 1 over x. Thanks for watching.